Bismillahirrahmanirrahim. Dear students, we are talking about the chapter number 16, grade 12, and the lecture number is 35. And we are talking about the reactions of alkenes. In the previous lecture, some chemical reactions I told you hydrogenation. Hydrogenation of alkenes we done in the previous lecture. Now in this lecture, we will do about the halogenations, means addition of hydrogen and addition of halogens with alkenes. So halogenations of alkene, grade 12, and lecture number 35, and the chapter number is 16. So for the halogenations, first I will give a simple example, just like ethene. So ethene is a symmetrical alkene. Symmetrical means both sides contain same number of hydrogen atoms attached with the carbon. This is called symmetrical. So this is the unsymmetrical reagent. Unsymmetrical means different, unequal distribution of electron present between the hydrogen and halogens. This is a unsymmetrical. So when this is going to react, so it makes no difference that this hydrogen going to attach here and the halogen is going to attach this carbon because both are same. It makes no difference. So you will get alkyl halide. Double bond is going to be removed, and you will get a ethyl chloride or chloroethane or ethyl chloride. This is the one reaction here. Reactivity is given here. Order of reactivity of halogen acid is hydrogen iodide. Hydrogen iodide is the most reactive. Then hydrogen bromide. Then hydrogen chloride. This is the reactivity order. Now, dear students, there is, if you have unsymmetrical, like protein, when you have an unsymmetrical alkene, unsymmetrical means this carbon contains 2 hydrogens and this carbon contains 1 hydrogen and this carbon contains 3 hydrogens. So this distribution of electron is unequal. So this valency of the carbon is such that there will be no addition here. So here in between these 2 carbons there is a pi bond, double covalent bond, so addition taking place in these 2 carbon atoms. So when you are going to add unsymmetrical reagent, this unsymmetrical reagent, then there is one rule. There is one rule, we will discuss later, this rule is given. That rule is called a Markovnikov's rule. Because reaction is given here, that's why I am giving you. First reaction is given here. First I explain the simple one, then I am talking about this one. So according to the Markovnikov's rule, if we have a unsymmetrical carbon alkene on both sides, different number of hydrogen atoms attached with the carbon containing double covalent bond, and you are going to add the unsymmetrical reagent which contains hydrogen partial and chlorine negative. So this rule states that negative part part of the reagent is going to be attached the carbon containing least number of the hydrogen atoms or no number of hydrogen atoms. This is the Markovnikov rule must obeys. So this hydrogen negative must attach with the carbon which has less number of hydrogen atoms or no number of hydrogen atoms. So this hydrogen should be attached here because the balance of this carbon is a complete satisfied. There is no need for adding this one. Your product will be like this. Secondary alkyl halide you will get. This is a secondary alkyl halide. The name of this compound is 2-chloropropane. 2-chloropropane. So this is according to Markovnikov rule. If you add hydrogen here and the hydrogen here, this is called anti-Markovnikov rule. This is the actual product which is going to be formed this one. So there is a reaction mechanism here. In the reaction mechanism, how the chemical reaction taking place? Reaction mechanism means path of the chemical reaction. How the steps involved. So this is the alkene mechanism. Mechanism of reaction. This is the ethene. And it is going to react with hydrogen halide. So the first, this is the pi electrons, these are nucleophile, rich in electron, nucleus level. And this hydrogen is the electrophile. So these pi electrons become nucleophile attached to the hydrogen. So what happens? This carbon, hydrogen at the same, double bond remove, hydrogen is going to be added, valence of this carbon is not satisfied, positive charge is created. This is the addition of hydrogen with the carbon. This pi electron being a nucleophile is going to be attached to the hydrogen which is an electrophile. Now at the second, this halide ion, these halide ions being a negative charge are nucleophile and this carbon is electrophile is going to be attached. So this is a CH2, Cl and CH3. So this is called a ethyl chloride, chloroethane. This is an ethene containing double covalent bond. Pi electrons are here. Electrons are going to be more. So these are the nucleus level and they are rich in electron, being as a nucleophile, hydrogen positive charge which is an electrophile. So nucleophile are this attack on the electrophile here. So hydrogen is going to be attached to this carbon. So you will get the methyl group here and double bond is removed, valence of this carbon is not satisfied, positive charge is created on the carbon. Then this halide which is the negative charge being a nucleophile, this is electrophile, electron deficient, this is going to be attached here and you will get the final product that's called a alkyl halide. Dear students, this topic now same I put here this Markovnikov's rule. Next topic is same. Markovnikov's rule. According to this rule, I told you, the unsymmetrical alkene, this unsymmetrical alkene propene, is according to the Markovnikov rule, which states that addition of unsymmetrical reagent, this unsymmetrical reagent which have partial positive and partial negative, to an unsymmetrical alkene, the negative part of adding reagent is the adding reagent, negative part is going to goes to that carbon atom which contains less number of hydrogen atom containing double covalent bond. So double bond is here, this less number of hydrogen atom. This covalent must be attached here. This is called Markovnikov's rules. The same example is given here. Here is okay. I am going to write. There is a no. This example is given in the book. This is unsymmetrical carbon containing double covalent bond. This and this contains does not any hydrogen. There are two hydrogen atoms are there, and if you add hydrogen iodide, most reactive. According to Markovnikov rule, this iodide must add here. This does not contain any hydrogen atom, and this hydrogen should be attached there. So you will get a product C CH3, and there should be a iodine and CH3. You will get this compound which is called 2-iodo-2-methylpropane. 2-iodo-2-methylpropane is the main product. This is the main product you will get. So, according to the Markovnikov rule, 2-iodo or 2-bromo methylpropane is the actual product according to Markovnikov's rule. So, if you are going to attach here iodine at the first carbon, then hydrogen should be here. Then this is not according to the Markovnikov rule and will be called not actual product. This is not actual product is going to be formed. So this may ask in examination in the short question, or maybe in the MCQs, or any type of question will be asked about the Markovnikov's rule. This is the Markovnikov rule. Now, second reaction is hydration. Hydration of alkenes. Addition of water. Hydration means addition of water. Addition of water to alkene is called hydration. Some reactive alkenes react with water in the presence of suitable substances like acid. We use here sulfuric acid to form alcohols. So conditions given I told you, because water is polar and alkenes are non-polar, so directly alkenes do not react with water, no hydration taking place. So in the presence of acid, mineral acid, sulfuric acid, and the product you will get alcohol. So alcohol is going to be formed in this case. It is possible an alkene are soluble in cold and concentrated sulfuric acid. They react by the addition to form alkyl hydrogen sulfate. These alkyl hydrogen sulfate on boiling with water to decompose to give corresponding alcohols. So dear students, this is a reaction I am going to write. This is the alkene, ethene, plus sulfuric acid H2SO4. This is the structure of sulfuric acid. H2SO4 is a structure. Now, students, same we use the Markovnikov's rule, but here it is a symmetrical alkene. Both sides contain equal number of hydrogen atoms. So hydrogen will be attached here. Double bond is removed, and HSO4 will be attached. This is the cold concentrated sulfuric acid. Cold concentrated sulfuric acid you have to add in water. So you will get ethylene, hydrogen sulfate. Ethylene hydrogen sulfate is going to be formed here by the addition of sulfuric acid cold. Then next step, this ethylene hydrogen sulfate now boiled. Boiling with water. So what you will get, this hydrogen will be added again here to make sulfuric acid, and OH is going to be added to give alcohol. The alcohol is going to be prepared, so you can prepare alcohol by using this method. So you will get a sulfuric acid, which was the only condition for the chemical reaction. Actually, we are hydrating the alkenes. This process is a hydration, alkene addition of water. So this is ethanol. Ethanol is going to be formed and sulfuric acid there. So this is the ethene and this is sulfuric acid. This hydrogen partial octave going to be attached here. If there will be an unsymmetrical, then hydrogen should be more hydrogen, and this hydrogen sulfate should be a less hydrogen carbon containing, but they are both equal. So hydrogen will be added here, CH3, then CH2, then hydrogen sulfate SO4H, then this ethylene hydrogen sulfate react with the water, boiling with water, you will get alcohol and sulfuric acid is going to be separated. So this is called hydration. Addition of the water with the alkene in presence of addition of the water in presence of cold concentrated sulfuric acid to get alcohol. This is called hydration. Now halogenation. These are the unsaturated hydrocarbons. So addition reactions are both possible. Addition of halogens, same. So when halogen is going to be added in the presence of carbon tetrachloride solvent, you will get dichloroethane. Dichloroethane, and we will do in the next lectures maybe topics also. These two chlorine atoms are symmetrical, and with the containing neighboring carbon atoms, so we call vicinal dichloride. Neighboring, same one carbon, adjacent carbon atoms. So we call vicinal dihalide also this one, vicinal. So alkenes react with halogens in inert solvent like carbon tetrachloride. At room temperature you will get 1,2-dichloroethane, and this is a vicinal dichloride or vicinal dihalide are going to be formed. Bromine and chlorine are effective electrophiles reagent. Fluorine is a too reactive, we will not use fluorine here, and iodine does not react. So we use mostly bromine and chlorine. Same as here, mechanical reaction is given for this one. If you write the mechanical reaction, nucleophile the ethene, and you are going to so yes, now you can have the nucleophile bromine. So when bromine is going to be attached and added with the alkenes, so this is the nucleophile pi electrons. So one end of the bromine acts as a partial positive, and other end of the bromine acts as a negative when approaches to the double covalent bond. When is going to be attached with a double covalent bond. So this is a nucleophile. This bromine is the electrophile. So you will get like this. For the time being, you will get this one, and sorry. The valence of bromine is going to be increased because you are seeing there are two bonds attached to the bromine. So ion is called bromonium ion. Bromonium ion is going to be formed CH2CH2, and this is the unstable. In the next step, this bromonium ion, so one of the bond is going to be broken down. If I break this bond here, this bond is going to be broken down. So this is going to be attached here. This one is broken down here. So you will get again vicinal dibromide. 1,2-dichloroethane. Bromine molecule becomes, I told you, polarized. This bromine molecule is going to be polarized when it is contact with the alkene, double covalent bond, pi electrons. It is going to be polarized. Partial positive and partial negative charge is going to be attached here. There's one thing more. This bromine molecule, liquid, we call bromine water, reddish brown color. Liquid bromine water we call this. Color is a reddish brown. So this approaches to this alkene mechanism you are seeing here. So the color of the bromine water is going to be discharges, colorless, decolorization, and you will get a 1,2-dibromoethane vicinal dibromide. So this is the test for unsaturation. This is a test for unsaturation. So if you have an alkane, ethane, and if you have an ethene, both are colorless gases in the test tube. Put the add small quantity of bromine water in both. So one test tube bromine water is going to be a colorless. Decolorization taking place. This indicates that the double bond is present, double bond compound containing present in that test tube. This is used as a test for the unsaturation. So this is bromonium ion form, and then 1,2-dibromoethane is going to be formed. The bromine molecule becomes polarized as it approaches to alkene. Already I told you. This polarized bromide molecule transfers positive bromine atom to alkene, resulting of the bromonium ion. Then nucleophile of bromide ion then attack the carbon bromonium ion. This is a nucleophile, this negative charge, this is the bromonium positive charge. To form the vicinal dibromide, already I told you. And the color of bromine is disappeared. This shows that double covalent bond is there. This is a test for unsaturation or double covalent bond, which is written in your book also. This is the halogenation. The second reaction is high-low hydration. Halohydration. The addition of halogen and also hydration. Halohydration. So we use the hypohalous acid. Hypohalous acid. So hypohalous acid is going to be formed here. I'm writing here. This is the water, and this is the hydrogen. So you will get like this. So this is the hypochlorous acid. So this is given in your book. Direct is given. Direct addition of this is given in your book, but I write separate here. So water when add halogen molecule, you will get the. If you add chlorine, then you will get the hypochlorous acid. But if you will add the halogen, you will get hypohalous acid. That's why halohydration we call it. So this hypochlorous acid, this is again symmetrical alkene. Both ends contain same number of the hydrogen atom. So it makes no difference that you add the hydroxyl group and the halogen on the carbon atoms. Alkenes react with the halohalous acid to give a halohydrin. This is a chlorine, we write chlorohydrin. this is a chlorohydrin. If I put X, then you have to write halohydrin, chlorohydrin. So chlorohydrin is going to be formed. Alkene react with the hypochlorous acid to give chlorohydrin. In these reactions, molecules of the solvent become reactants too. So this is a chlorohydrin. General reaction is given in your book for the halogen, but down you can see maybe chlorine or maybe bromine. So you can do for the bromine here hypobromous acid, then you will get bromohydrin. If you use chlorine, then this will be a chlorohydrin. So then the other chemical reaction is epooxidation. Epooxidation and epoxide. Epoxidation is formation of when you add per acids. Per acid. This is a per acid, acetic acid. This is a per benzoic acid. Per acetic acid, per benzoic acid. This is a per benzoic acid. And this is a per acetic acid. So we use per acids in the epooxidation. So if you use propene, so there is a per benzoic acid in the presence of chloroform. Propene. If you use per acid, if you use per benzoic acid, it is your choice in the presence of chloroform as a solvent. So this one oxygen which is extra, we call per, attach with these two carbon atoms to give epoxide. Benzoic acid is going to be formed. So this is called propylene epoxide. This is epoxide. Between the two carbon atoms, if oxygen is attached directly, this is called an epoxide. There are three carbon atoms we call propylene, epoxide. This is the epooxidation. In the formation of epoxide, per acid such as oxyacetic acid or peroxybenzoic acid are going to be formed here, react with the formation of epoxides. The propylene react with the per acid, per benzoic acid, per acetic acid to give a propylene epoxide and the benzoic acid. So this is the epooxidation. Photolysis. addition of ozone in alkene is called ozonolysis. The reaction is very fast, vigorously, and this form unstable we call molozonite, and then it rearranging to form a ozonide here. So simple reaction first. Ethene, ozone to form molozonide. This is called molozonide. This is unstable. There will be a rearrangement, and this oxygen will go here, and this bond is being broken down. This bond is broken down, oxygen will go up like this. This oxygen will go here, like this. This is called ozonide. Ozonide is being formed. This bond is broken down. No more bond is there. And this oxygen is going to be go here. This is the ozonide. Now in the ozonide, what happens in the presence of water? In the presence of water, this bond is going to be broken down, and you will get this is the carbon, and this is the hydrogen, and hydrogen, oxygen. Same, this is the carbon, hydrogen, hydrogen, oxygen. Bond is broken down, this oxygen is gone. So students, you will get aldehyde functional group. Same. So we will get two aldehyde molecules and hydrogen peroxide. So this hydrogen peroxide react with zinc to form a zinc oxide and water. So this is the ethene, alkene ethene. This is the ozone. So first form ozonide, 3 oxygen atoms attached with the alkene, and then there is a rearrangement. This oxygen will go here, bond is this vanished, and you will get ozonide. This is ozonide. Then this bond is broken down, this bond is broken down, this bond is broken down. These two parts separated, oxygen with water, to form the hydrogen peroxide, and this formaldehyde. Formaldehyde with ethanol is going to be formed. The same aldehyde are going to be formed. Hydrogen peroxide. This hydrogen peroxide reacts with zinc to form the zinc oxide and water. So this reaction is called ozonide. Reduction taking place. The last reaction is a polymerization. Poly means many. Merization means parts. So how the plastics going to be formed? Ethene, alkene, many number of atoms, n number of atoms, they are going to be self-mixed at very high temperature, 400 degrees centigrade, about 100 atmospheric pressure, and traces of oxygen, you will get polyethylene plastic, polyethylene. So a good quality of polyethylene, if you use the good catalyst, that's called aluminum triethyl or titanium tetrachloride. Titanium tetrachloride and aluminum triethyl, if you use a catalyst, then the good quality of the plastic is going to be formed. So when the monomers combine with each other to give a big molecule, that's called polymer, and the process is called polymerization. So this ethene, and molecules, they are going to combine at 400 degrees centigrade, 100 atmospheric pressure and present in the catalyst. You will get polyethylene or ethylene molecule. You will get like this one. This is the polymer. There is no end, no starting. Like this. This is called polyethylene, and this is the same original one. But the valence is not satisfied, double bond is gone. So we don't know how many atoms here, we don't know how many of them. So this is a huge big. This is called polyethylene molecule is going to be formed from the ethene. So ethene used as a petrochemical. So dear students, we finish here the properties of alkene. So inshallah next lecture we will study about the conjugation. So very important this chapter and very big chapter we organ process. Thank you very much.